Hello, our topic today is linear function, concept of slope, and how to get slope-intercept form from point-slope form. First of all, we need to define what a linear function is and how it is represented on a graph. A linear function is a function that can be graphically represented by a straight line. In order to identify a linear function in a Cartesian plane, you just need to remember that the graph of a linear function is always a straight line. For example, here, you can tell it is a linear function because a straight line is graphed. Now that we have that clear, we can go on. With a linear function, we can also find the slope. How, you might ask me? Here we have a pair of points, and now I'm going to show you how to get the slope. Remember that the slope is the ratio between the rise and the run, and that it measures the rate of change in the dependent variable as the independent variable changes. Back to the task in hand, the slope of a line is usually represented by the letter m, okay? So slope equals to m. x1 and y1 represents the first point here. So this one is x1 and y1, right? And these 2 points are x2 and y2. We need both points in order to get the slope. The formula to get the slope is simply m equals, let me write here, m equals y2 minus y1 over x2 minus x1. Now let's get the slope of this linear. Here we have the y2 is a 3. So we just replace what's here in the formula. That is going to be 3 minus, here's a minus 1, so we put minus 1. And then over, here x2 is 4, so we put 4, the minus here. And here is the minus 2, and we put the minus 2 right here. Now the only thing we have to do is just like solve it. Here is gonna go 4 over 6, but this fraction can be simplified. So the slope will be 2/3, and that would be the answer. M equals 2/3, and now we got the slope. Once you've mastered this, we can continue. To get the slope-intercept form from point-slope form, you must first know how both forms look like. Here in the top, we have the point-slope form, and in the bottom, we have the slope-intercept